Explore the history, relationships, expertise, and data that go into ensuring Stine growers get maximum yield potential. This is the Stine Seedcast. Here's your host, David Thompson.
Hello, and welcome to the Stine Seedcast. I'm your host, David Thompson, National Marketing and Sales Director for Stine Seed Company. We've got another great episode lined up with special guests, expert insights, and discussion on everything you need to know about maximizing yield potential. On today's episode, our special guest is Tyler DuBay, soybean technical agronomist for Stein. Welcome to the show, Tyler.
Hello, David.
Well, Tyler is well-versed in soybean research. As a soybean technical agronomist for Stein, he's been tasked with evaluating our research and development plots in Illinois and conducting soybean product evaluations during the summer. His number one goal as a Stein agronomist is to help bring awareness and knowledge, both internally and externally, as to why and how Stein has and will continue to have the best soybean genetics in the industry. Today, we'll discuss what differentiates Stein soybeans from the pack and what sort of new innovations we employ to keep Stein ahead of the rest of the industry. So let's get started. So Tyler, maybe just initially for a little bit of a level set, one of you tell us a little bit about your background and how you came to Stein.
Yeah, so when I was little, I played ice hockey, and Chuck Hansen actually was our hockey team manager. And one day I wore an ag hat to hockey practice one time. He's like, "Oh, I'll get you a really good hat," and he brought that over, and yeah, that's how I got introduced to Stein. So, but yeah, no, when I was 14, my mom forced me to get a job. So I first started detasseling corn and pollinating corn, and I did that. Worked in yield trials, counting plants, and doing root digs and stuff like that up until I graduated college.
Okay.
And then, I continued after college working for a big company and worked in their parent test group. And so I was on the production research level. So it was kind of in the mix of research and development and seed production, doing different tests and stuff like that.
Oh, cool. Finally,
I wanted to differentiate within my career, and I gave Chuck a call again, and the world is a small place. And so, I ventured over to Stein and worked for Stein for 2.5 years and had a tremendous amount of experiences with Stein the first go-around that I was here. Went to all their winter nursery locations, did all their yield trials, and was a part of some really cool, innovative stuff. So, and then I met my wife. So met my wife and wanted to start a family. So, kind of ventured around and did some corn seed production stuff, seed production research stuff for about 6 years, then came back to beans and was with a small company for food. It's a food technology company.
Okay.
So they focused a lot on composition within seeds and nutrition and stuff like that. And then I gave Chuck a call again, and, I miss Stein. I honestly tell everybody this, that I would never have left Stein if I didn't meet my wife.
Oh, don't hang that on her.
No. No, she gets a laugh out of it every single time. But no, when I was here the first time, it's like a band of brothers. I experienced life with them. I had many great experiences, and I honestly missed it. So that's what drew me back to Stein. And it's like the Stein culture. I come back and everybody is open with welcome arms, and it's like I never even left. So it's been great to be back for sure.
Awesome. And so now you're back with us in a different role. So I wondered if you'd talk a little bit about your objectives in the role that you're in as soybean technical agronomist.
Yeah, so every day in the summer, I work in the research and development fields. I have 8 locations scattered all across Illinois. I do both corn and soybeans, look after those research plots over there. So I'm heavily involved in the research and development group every day. And I also work with Tom Larson and the agronomy team to tell them what's going on within the R&D group. So I'm kind of a liaison, I would call it, because I keep them in the loop of what's coming, what's going on, and also what's going to be launched here I wouldn't say launched, but what's going to be released out of our soybean program. So they know what to expect in, their PDP plots,
Product development.
Product development plots. That's kind of a tongue twister. But yeah, a lot of those new varieties are going to be launched into those. And so I'm a good resource for them to know what's coming and also give them some aspect on if they're seeing something weird within a soybean customer's field, that, you know, I could be a good resource for them and give them a good idea of what's going on and what I've seen in the past. So.
Well, and I think that's an exciting opportunity for us as an organization, because one of the things we've done over the years, of course, we've always been very quick to turn products because it's about the newest and latest stuff, right? And as that has accelerated, I know from the sales side, it makes it more challenging, right? Because growers get used to a certain variety or a certain hybrid or whatever, and they get comfortable with that. And so
that's right.
So having you in this role, or having, you know, even on the corn side, Warren Stein does a good job of that for us on corn as well, sort of bridging that gap, right? So that we can see what's happening on the research side, kind of get a feel for what's coming down the pipe, and kind of connect those two realms, right? Research and sales, because like I said, we're not going to slow down, right?
No, so only going to get faster.
It's only going to get faster. So we need that kind of information as quickly as we can. So anyway, glad to have you back. I think it's a great opportunity for us as a company, and we're excited to see where this goes. So I asked you on the podcast today, I want to talk a little bit about the kind of the soybean breeding program as you've been working with it, because again, this is your second tour. You've been involved with the program before, and now, you know, a few years later again. So always love to talk about that, because that's kind of the engine that drives everything that's going on, right? Is where the genetics come from and how they're derived. So talking a little bit about, you know, soybean breeding, I guess, what is it that makes a soybean breeding program successful?
Numbers.
Numbers, yeah.
Numbers, lots and lots of numbers, testing and speed. Timing and speed and numbers are extremely critical. If you only have one to pick from, then you're limited by sheer numbers. So the Stein program, I believe, has the highest amount of material going within their breeding program, and they're extremely fast. You know, we have winter counter seasons, so winter nurseries that we utilize in the winter, and that's down in South America. You can get upwards of 4 generations a year, whereas, you know, here in the U.S. you only get one. So
right.
There is a chance where you can get up to 3. You know, as you grow here in the U.S., you can send seed down in the wintertime, and by the time it comes back, you've already seen its great-grandchildren are coming back. So that's the fundamental thing. And as you, again, increase the numbers, it gives you more of a selection. If you look at it kind of a upside-down pyramid, you know, if you early generation stuff, you have a whole bunch of stuff, and you just keep cutting it down until you get to the commercial end, where you have that one fantastic variety that'll just knock people's socks off. So, so you throw away really bad stuff, and they don't produce, and you just continue to grow and test as much material as you possibly can. And then also what I would say is that the reason why I say timing is because if you're off track within timing, within a breeding program, it's a long haul. It's a very long haul. So we don't look at current season. You know, we don't look a year in advance. We look at 3 or 4 years in advance, because if you start a cross in the summertime, you need to have your timing set up as you go through the years. And if you get late on anything, then you're just falling behind, and you run behind, and you can't get So for instance, if you get stuff out late in the wintertime, you can't test it that following summer, because then you may run out of the planting window, you may not get good data. And so timing is everything as well.
Yeah, to your point, one of the challenges of off-season production is just timing.
Yeah.
It takes time to get it moved around. It takes time to get it planted and grown. It takes time to get it back. And if you miss that window, you miss that window.
Yeah.
You know, it's just not like you can say, well, just...
And that sets your whole program.
And then
you know, it's not like you're sending one variety. You know, you're sending thousands and thousands and different lines, and, you know, you don't want to be put behind the 8 ball almost. So
you mentioned volume, and I think that's something that's been a hallmark of the program for a long, long time. And one thing I know Harry has talked a lot about is the idea of just volume, and I think that's probably such an important part of the puzzle.
Yeah,
because the analogy is, of course, we're going to have a basketball team, and you get to pick from this pool of 50 people,
Yep.
and I'm going to get to pick from a pool of 1,000 people. Well, what are the odds that you're going to pick a better team out of your 50 than me, who has a much larger pool to work from? And I think that's a really succinct way to think about the importance of volume. Now, the problem with volume is there's a limit, right?
Yeah.
How much you can do in a day. But I wanted to talk a little bit about that in terms of the numbers. If you can, what are some of the numbers that, Stein is looking at in terms of evaluations? Like, what's the lay of the land as we look at the summer here of, 2023 and what the program looks like?
Yeah, so across the Corn Belt, we're across 13 states within the research group. We have 1.2 million plots, and those are all planted within, I would say, April and May. And so the planters that we have are fantastic. They are very fast, and the people that are on them are fantastic too, because they work harder than anybody I know. So so we have about 115 to 118 locations spread out through the whole entire Corn Belt. It goes all the way down to Arkansas because there's a station in Forest City. We have about 6 different stations set up within the whole program. There's Horace, which is up by Fargo. There's Adel. There's now Peoria, where I'm actually located, and then there's Sheridan, Indiana.
And so they kind of have responsibility for, I would assume, a set of products that are more than likely, I assume, grouped by latitude. Right?
Yep, by maturities.
Working with, a certain maturity range within that given area that they operate in.
Yep, for sure. Yeah, they cover all their maturity groups, and they're spread out pretty good. I know Indiana, they go all the way down to Kentucky, and they go all the way up to Michigan. So yeah, they see a whole bunch of different products, and the fields range from anywhere to 4 acres all the way up to 80 acres. So I mean, it's a big logistical effort on our part as well, and so it's something that needs close coordination.
Well, and that's a good point. You bring up logistics. I know here from where we are in our Dallas Center campus here in Iowa, a lot of the winter we see packaging of seed. You said there's 1.2 million plots.
Yeah.
There's a lot of envelopes of soybeans being packaged throughout the winter months. And I don't recall whether, I know that a large portion of that gets packaged here.
Yep.
I don't know if it's all of it or if there's some that happens to the outlying locations, but I guess, then each of those locations, the outlying locations, are responsible for their plots within their area, right?
Yep. The vast majority are packaged here.
Okay.
And I know that Arkansas and Indiana did some packaging this past winter to help alleviate that, because like you said, 1.2 million is a lot for for a group of people, and many hours worked. So they spread the love.
Yeah. Well, like I said, it's amazing. When you think about 1 million different plots being evaluated each and every year, that speaks to that volume part of the equation. So just phenomenal.
I would like to add, too, that within our elite trials, we go about them differently from the aspect that so the elite trials are about to be commercialized.
Okay.
So we want to plant them at the time the farmers are planting. Within research organizations across the U.S., they're worried about frost. So they don't plant usually within the month of April, because you get one shot at a research trial location. But at Stein, we don't care. We want to be planting when the farmer's planting, so our data is highly valuable, and we can at least tell them, hey, this was planted in your region of the United States. This is what you saw, and this is exactly what we saw at the same planting time.
And that's a great point. I think also we in the past have talked about people asking about on the value of this research seed. Do we put any special treatments or things on it? And correct me if I'm wrong. I mean, we don't treat the seed that we plant, because we really want to subject it to, don't want to say the worst possible case, but the base case, right?
Yeah. We want them to be stressed out. We want them to see how they yield through it, and that's what we do, because if you put treatment on it, it only gets better from there. So
right.
if you put them in the ground and they're not covered and they still yield like crazy, then it's only going to get better from there. So
so the goal is, let's see what the genetics themselves can do.
Exactly.
Like you said, in a real world environment. Planted when farmers would plant them, treated as farmers would treat them, and then you can do all kinds of additive things to hopefully preserve that yield. But let's just see what it does out of the gate.
That's right.
So I wondered if you'd take a minute and talk a little bit about, sort of the timeline and the process of this whole process of getting from, the start of soybean breeding and development to the point when a farmer might see something that shows up in a bag, just generalities.
Yeah, so I break it down into 4 different phases. At first, you start with crossing. It all starts with crossing. At Stein, we do about 20,000 crosses within a given year within the program. And what that translates to, just to understand the scope, is the people that do the crossing touch about 250,000 flowers. And so in order to get those 20,000 crosses, brand new crosses, you have to be aggressive with the flowers because not every flower will actually produce what you want it to. So,
and just by way of background, talking a little bit about crossing, I mean, for those who may not be familiar, wondered if you just spend a minute and talk about what that really is, because I find that fascinating.
Yeah, it's crazy. But no, you have a male and you have a female that's identified within the program, and given certain traits and what they want to do, and then you go pick the male flower because they are complete flowers, and so you have to force pollination on it. And so what you do is you go grab the male flower, and then you take the soybean and you pull the sepals back on the female flower that's just about to start flowering. It's not quite at the flowering time because once the flower's out, it's done.
Yeah.
So you got to pull the sepals back, pull the petals off, and then you put the male flower. You get the anthers and everything off of the male flower, and you just put it right on top of the stigma with a tweezers. So you do everything with tweezers and a magnifying glass, and you're inside the canopy of the beans. And so I applaud everybody that actually does it because patience is a virtue, and that's a real thing. So
you do that 250,000 times, and then you're done.
Oh yeah, it's unbelievable.
Well, I would say, in the past, I've been fortunate to have groups of farmers who come to visit the farm in July. And one of the things that's always fun to do is to have them watch a cross being done. Because you're right, there's a lot of work involved. As you said, they got to go out and find the donor flower and then capture that and put it in an envelope. And they got to come over to the row that they're going to make the cross on. They literally are sitting down in the row.
Sitting down with an umbrella sometimes.
And peeling that flower apart and then making that hand pollination. And I think when farmers see that, they often say, okay, now I understand why not everybody does this kind of work. I mean, it's just a tremendous amount of work to create a brand new soybean line.
Right.
So that's really the first step of the process is getting crosses made. Of course, then, that's the only cross on the plant, most likely, right? They tag them. And
they do multiple crosses on a plant. Because the soybeans will just continue to flower, over the process of the year. And so, you may have 2 or 3 or 4 different crosses on a single plant. And so you use tags to keep identification of what actual cross was done on that node or that flower on that plant. So when it comes back to harvest time, you can go back and you can pull the pod off and you pull the tag off, and you know exactly what was done back in the flowering window.
Yeah, because they also, if I remember right, that tag says where the cross was made, the date it was made, who made the cross. A bit of bragging rights there. I think there are certain individuals who are very, very good at it, and so
there's a certain pride in it because they take percentage and stuff like. I've seen people get upwards of 60% take percentage, and that's quite impressive.
They're a rock star in the soybean world.
That's the top that I've ever seen. I mean, I'm sure there's people that have done a lot better, but.
So then in the fall, they come through and they collect all of those pods that are actual crosses.
Correct.
And that's really your first sort of new genetics.
That's your new F1 genetics. And then, we take them to winter. So the goal within the second phase, which I call development phase, the goal is to just get seeds, get as many turns or cycles as possible. And so that's when we send them to the winter nursery. And that's where South America really comes in handy in Central America, because you can get the four cycles in a year. And so by the time when you set and timing, remember I go back to timing, if you're late on harvest down there, then that puts you behind on your double cycle in the wintertime. So you plant in September, October, then you harvest again, harvest that seed down in South America, January, February, time frame. And then instantaneously you harvest those and you replant them within the next couple days, you know. So it's just turning and burning, I guess is what you can call it. So
yeah. Correct me if I'm wrong, because I think on the corn side, we've talked about this as well, the fact that, you know, at that stage in the process, Guyana, for example, is a little different environment than it is, you know,
I've
here in
been
the
down
Midwest. But it's not really about, you know, maximizing yield per se. It's back to what you said. We're not trying to get a high yielding plant right then. We're trying to get a plant to mature in the quickest amount of time we can to turn the seed. It's about time.
That's exactly right. That's exactly right. And that's been, you know, across the industry, that's a struggling aspect that people are trying to figure out is how do we go faster? Because if you can go faster than your genetic gain, which your genetic gain is your offspring being able to beat your parents, right? So the more you get genetic gain, the more yield you're going to get, the more products you're going to be able to release, and the more advantageous you are going to be to the market.
So ultimately, if you believe your program is successful in finding newer, higher yielding material in the subsequent generations, then it's simply an equation, right? As many generations as you can turn increases your genetic gain.
Exactly.
Right?
Exactly. And so, I always kind of use it as layman's terms. You know, I always hope my kids are better than I am at everything. So that's the main goal within the breeding program. And it's true because, you know, as over the past 30 years, many people thought that yields are just going to stabilize and, you know, be constant. But as we see every single year, it just keeps going higher and higher. And it's pretty interesting to see and an exciting time within breeding and the ag industry.
So when we get done with that kind of blow up phase, getting these products, getting a quantity of seed, right, that we can kind of work with, then where does it go from there?
Yeah, so after the F2 generation, so you're the F3s, so when it comes back from winter, right? Yeah. So then you have these individual plants. So you pull from a plant and you take all the seed from that plant and plant it out into a row or multiple rows. Mm-hmm. So that's what you call a population.
Okay.
Because each individual plant is going to be different.
And I think that's something, again, when we've had, you know, farm tours, I think that's something also that sometimes people are fascinated by is the idea of these, you know, bulk populations where let's say you have a 30-foot row, there's 100 to 150 plants in that row, and you say these are all the same, they all have the same parents.
They come from the same lineage.
Right, they're all A by B, right? They're all the same parent, but they all look different. Yeah. And it's like kids in a family. It's just the genetics have recombined in a lot of different ways. And that's where you get the benefit of this breeding program, being able to look at numbers and create just a vast number of products from just one genetic combination that you've chosen to make. Right?
Yep, that's exactly right. And so that's where varieties are really born, because within the process of crossing till that point in single plants and you're seeing them in rows, you're trying to get the segregation or the differentiation of all those plants out. You know, you're trying to get the traits that you want, you know, from RPS genes and stuff like that. You want to get those fixed within within those plants. And so as you go through and you plant them out in the rows, then you start picking out single plants again. So because if you start doing the single plants, then that turns into the variety. And by the F3 generation, they're, for the most part, fixed. Like, they're not going to segregate that much more. I mean, they will to a certain point, just from like a pubescence, you know, and stuff like that. But for the most part, they're going to be fixed for those RPS genes and stuff like that.
But I would assume at that point, as you starting with that bulk population, now you have a whole bunch of plants that are really, among other things, segregating mainly for maturity.
Yeah.
And that's kind of how we sell soybeans. So I'm assuming at that stage you have to start regrouping these sort of in maturity combination.
Well,
right?
you take the single plant and then you plant it out again into a row. And that's where you take it down to winter again. And that's where we still do maturity flights on those, because you can see, okay, this one's supposed to be a 2.0, but it's actually a 2. What it's acting like is acting like a 2.7. So you discard it or you throw it away. And so that's why, again, I go back to the numbers game, because as you go to the single plants and it does something that it's not expected to do, you just constantly are throwing stuff away.
Yeah. And so now we're at the point where, of course, everything we've talked about at this point, we still haven't evaluated anything
No,
on its merits,
not
right?
yet,
We haven't evaluated yield. So now, am I correct? Now we're moving to the stage where, okay, now we have this material.
Yep.
Now let's figure out what we have. So how does that process go?
So you take you grow them out in the single rows and you harvest those, and then it moves on to the testing phase. And so, yeah, to your point, you bring that seed back from that row and you plant it out in yield trials. And you can get upwards of, 4, 5, 6 locations worth of information. Use your yield data to tell you what needs to be moved on. And at the same time, they're actually growing increased seed. So within our testing program, we actually have a yield trial program and we have an increase program at the same time. And so that way, when we move stuff from the yield trial program and we move it on to PRYTs or the later advanced stages, we have this tested pure seed that's not touched, and we combine that and use that to keep increasing. So there's 2 parallel workflows, I guess is what you could say. There's a testing phase and then there's an increase phase. The increase is always funneling into the yield trials. You could use the yield data from the increases, but that's not what it's meant for.
And correct me if I'm wrong, the other side of that also is, so at the same time, we haven't yet decided which of these products is ultimately going to make it. Right? And yet somewhere in our system we may be growing 1 or 2 or 5 acres of that line.
Oh, yeah.
And it may be for naught because maybe that product's not going to pan out. So we literally have hundreds, if not thousands, of these little increases all over the place on the hope that we're going to find that product that's going to advance. And the reason I think that's kind of interesting is it sounds to me like that's a little different than how other companies would normally approach that, right? Most companies, I think, would get to the end of their testing program and say, okay, this product, whatever, ABC, has, done the best. And so now let's start blowing up seed and making a quantity of seed for that. But at the point when we've made that determination, we may already have lots of units of that because we've already been growing seed at the same time.
Right. And I've seen programs too where they actually use the yield trial seed as a source to move on to the next one. So they're not, at the same time, they're not purifying the seed. Okay. You know what I'm saying?
Yep.
You're using your yield trial and so the combines that we use, there's an option to bag. Or you could carry these little 5-pound bags around with you, and as it's going through the combine, you can save that seed, bring it. That's what actually they used to do, honestly. That's what Stein used to do, but then numerous years ago, they moved to this workflow where it's all separate. But we would bag the seed from the yield trials and use that as a source for the next year, which, again, that goes to the one of the benefits of the workflow that we have established now is you're actually testing what's going to be commercialized.
Yeah, so you're saying, so in addition to my idea that there's, you're blowing up seed in anticipation of some, pick, in addition, you're saying you're also able to purify that seed and work that seed in a different way than maybe what had been done in the past.
Oh, for sure, 100%.
Oh.
100%.
Okay, awesome. Well, and one of the things, somebody else in the industry one time said nobody else in the industry is better at taking 5 pounds of seed and making commercial bags than Stein. And I kind of get what they're saying now that we hear these stories and talk about the system and the workflow. So
yeah, I mean, it's a lot of work to bag on the road, because as you talk about maturities and we test in certain maturity areas, right? So when we used to bag, you'd have to bag up in Minnesota. You'd have to bag in Mankato, Minnesota, and drive them all the way back to Adel.
Yeah.
So I mean, it was a feat because you would have to bag on the road, bring them back, and throw them around all over the place. And props to those guys that like Rodney Pennico and Doug Beavers and all those guys. They did everything the hard way, and we got it easy now with technology because it's crazy.
Well, and to put it in perspective, I don't know if I have the numbers right, but I think Rodney telling me one time, when they harvested, if you're keeping seed, I felt like he said maybe 1,200 plots a day was you were doing pretty good. And now that, if they just store the data, they can do like double that.
Yeah.
And I don't know, with the R2 system now, it's probably way more than that.
Yeah, it's even way more than that because at that point you're doing a plot. You're doing 2 plots. So with the old equipment, we do 1 plot at a time.
Yeah.
And it would be about 10 seconds that you could do one plot. Now with the R2s, you can do 2 plots in 6 seconds. And so
it's almost half the time and double
you've
the
effectively,
material.
2.5x what you did before. And so that's the exciting. And if you want to know something crazy too, the combines are still the limiting factor within our program.
Really?
Yeah, they're still what's slowing us down. So, as new technology comes around and the industry changes, it'll enable us to actually evaluate more products, and the numbers game gets even bigger after that.
Well, we had the Clems from Almaco on the Seedcast here last year, and I remember them talking about, the work that the team does here really drives what they do in terms of innovation and improving workflow and improving systems and improving the equipment. And so in many ways, their equipment has come into fruition much
because
basically
of
using
Stein.
us as a research and development process. Because I think the kind of joke was, if the Stein guys can't break it, then it's ready for release.
That's exactly true.
And because we're hard chargers, we do that. And so I think that's fantastic. So you mentioned technology. We talked about the new R2 combine, so that's a good segue into what I was going to ask next, which is, we talked about these cornerstones of breeding, speed, efficiency, volume, all of that. And obviously, like you said, the bottleneck, there's always some bottleneck to that.
Yeah.
And at times it can be just hours in the day, right?
Yep.
There's only so much time.
And Mother Nature.
And right, exactly. And so I wondered, as we've gone, over the years here, especially recently, I hear these stories about ways that you're using technology to try to improve the throughput, the amount of, which in turn then gives you the ability to do, to increase. Maybe you go from 800,000 to 1 million, or 1 million to 1.2 million, or whatever. So what are the kinds of technologies that are being used today that maybe weren't 5 years, 10 years ago? They're helping to increase the number of plots that can get done in a year.
Yeah, so the hot topic nowadays is the drone work that's being done. We work with multiple companies doing maturity notes. So with those, we use red, green, blue cameras. So it's just like a regular camera is what I say, because if you see the picture, it just looks like a picture. So, but yeah, the drones fly over and take pictures of the plots as they're drying down, as they're maturing, and they could actually generate algorithms to tell us what the maturity is of that field, or not of that field, but of that plot.
Okay.
And so that in itself revolutionized almost everything for Stein, because
So for comparison, prior to that technology existing, how would maturity notes be done?
So we would go out with a tablet. And an application was made. And so you'd have to walk between every single plot. So for instance, our IDC plots, right? We have 49,000 of them in Minnesota. Somebody with a tablet would have to walk in front of all 49,000 of those plots and give it a score. It would probably take you multiple days. Or if you had a group of people, it would probably take you, a couple days.
Okay.
And it would give you a subjective bias opinion. But if you do it with a drone, it takes you 15 minutes, 10 minutes.
So you fly the drone, takes you, 20 minutes, and then you mentioned subjectivity or objectivity, right? So the drone's taking an image, it's applying this algorithm to decide to assign a score to those products.
That's exactly right.
And certainly our team's as good as any at being able to assign those scores. But to your point, there is subjectivity to scoring.
And there's human error too, right?
Sure. Yeah.
I mean, we go through and could hit the wrong number or not type in the specific number that we need. And so I like to explain to people, as you go through and you start on plot number 10 and you got 1,000 more to do, your opinion's definitely going to change by the time you get to 200.
After you've seen a bunch of it. Yeah, that's right.
Yeah.
Okay.
I mean, you can calibrate before you start, but your calibration is going to get all sorts of messed up as you go through the field and as you see different things. It's just how human behavior is. And so, I'm not saying that it's bad, because it's always people always need to be out in the field.
Yeah.
Like, that's never going to change. We're always going to be out in the field. We're always going to see things and learn things as we go through. But computers and drones and imagery can help us a ton just by taking a biased opinion out of it and just tell you what's going on and how the genetics are reacting to the environment.
So drones and imagery, especially as it relates to maturity and some of these other things, evaluations are certainly one thing that helps the program be able to look at as many and evaluate as many products as they do. Are there other mechanisms or other technologies that the team is working with?
Yeah, well, I'd like to go back and kind of add on, because there's also another revolutionizing thing that's happening as well with the drone work, is you can use different cameras within a drone, and this would help blow up numbers tremendously is by using yield predictions. And so what I mean by yield predictions is you could use cameras to identify a projected score or a projected ranking of how actual soybean within a research plot is going to do. There may be the possibility where you can create something where, you look and see the imagery and it could project out how that variety is going to do within the certain test, and you can not have to combine it. As I mentioned before, combining is the limiting factor right now. It's what's holding us back. And so if you can find something that would take combining off the table within the early generation stuff, I want to say that first of all, because we're always going to combine our elite trials. You can never replace raw yield data. But, our program is so, remember the upside down triangle, right? Yeah. Within the testing program, our early generation stuff takes up 75% of our program because it's all filtered down, right? And so if you can create a certain technology to evaluate those early generation projects and not have to combine them, you could actually reallocate all your combines to doing more elite trials and more testing of those elite trials, because that would give you more information, that would give you more plots, and you can even put more early generation stuff out there and test those.
So you could ultimately, instead of saying, 1.2 million is about as much as we can do, someday you may say, we can do 10 million, and we're going to weed out, 99.8% of that using predictive analysis to be able to say, we know, that these aren't going to cut it, so we just don't even bother. And then we can radically increase the number of products that potentially make it through elite. Not increasing the percentage that get through elite, just increasing the absolute throughput of the system.
Exactly, yeah.
Oh, wow.
And you can test more locations. You can test larger elite locations. It's kind of it's really an exciting time to be a part of ag.
Kidding. So. That's really wild.
So that's the really big thing now, is with combining being the limiting factor, there's multiple companies and but including ourselves, we're looking for ways that we could, reallocate resources and do non-destructible combining on the early generation stuff. So that way we can focus and get raw yield data and scores on the elite trials, because you'll never replace it. We don't ever want to replace that.
Right. But for that, like you said, that first cut where you're getting rid of, 95%, wouldn't it be nice to be able to, again, use predictive analysis and say, we don't even need to go in and harvest that.
Right.
We know what we're looking at, or we know with a high rate of probability that this stuff's not going to cut it.
Right. And then you can take from, like I mentioned, there's 2 different workflows, right? So you wouldn't even have to touch your yield trials. You could take from the increase and move those on.
Just move those on.
Yep. So you don't even have to touch those. So
that is exciting.
Yeah. So, cool. But there's all sorts of different new technologies going on, with markers now, and those options are always fantastic. And gene editing as well. That's big revolutionizing thing with CRISPR. So it'll be interesting where everything turns. So.
So, as we're kind of winding down here, Tyler, I guess, you've talked a lot about the things that Stein has done either over the years or is doing today. We're really proud of the work that all the research team does and the effort that they put in. And I think that's what's made the Stein name synonymous with high-yielding soybeans. I guess I wonder, what of those things that we're talking about, what are those sort of X factors that really separate what Stein does from what anybody else is trying to do in that same sphere?
I would say that it's what Stein isn't doing, honestly, because Stein to me is extremely focused. You know, you get companies all around, they're trying to do all these integral things, and Stein has one objective, and it's just to provide yield, high-yielding products to farmers. You know, that's what it is. You don't have people going out into these single rows and looking at how the plant looks, how beautiful it is, you know, how many branches it is. Yeah. It's just, is it yielding? Is it not yielding? If it isn't, no hard feelings, right? You don't even grow attachment to it. So, you know, just the fact that they're extremely focused on high yield products and they don't pay attention to all the noise around, that's what separates Stein from everybody else. And also, I would say their conventional program separates everybody else, because the conventional program is the highest yielding program, or is the highest yielding part of the program. That's where they derive all their parents. That's where, you know, all the really good genetics come from. As you know, the rule within breeding is if you add something to it, something else, you know, takes, right? There's a give and take to it. And so if you start stacking herbicide traits onto it, your yield starts to go down. Or if you start doing certain seed composition things to it, the yield starts going down. So the fact that we have as large of a conventional breeding program as we do, it's extremely impressive, and everybody wants a part of it. Everybody wants a piece of it. So I you know, when I talked to Chuck, he mentions it's egotistical of him, but he used it as a sales play, and it resonates with me because it's like, no matter what you do, you're going to plant our beans because everybody wants a piece of it, and it's true. That's the reason why.
Well, and it's a good thing talking about the conventional program too. You know, I've often said to growers and kind of explaining that process, conventional program's a breeding program that's been running for 50 years.
Yesterday in our research meeting, Bill Eby got up and he said, this year is our 56th year of yield testing.
Right. And so I always say breeding programs are kind of like a steam train, right?
Yeah.
So it takes a while to get a head of steam built up. But once it gets going, you've got a lot of momentum. And so every time some other company comes out with a new event and they have to start a new program, that's like starting up a new steam engine or steam train and trying to get it up and going. We've got this steam train that's been running for 56 years.
Yeah.
And let me tell you, it's moving. And so get out of the way.
Yeah.
And so the beauty of that is you don't want to stop. And so many companies, you know, certainly in the 90s, I think, looked and said, oh, the advent of traits, now we need to move everything over. Well, they all stopped their steam trains and got on a new train. And for us, I think it's just been fantastic to have that program that's been running so strong for these 56 years.
Yeah, yeah. And that just shows the dedication and hard work, you know, of all the guys that have been here, you know, like Ryan Main, Doug Beavers, Rodney Pentecote, those guys have all been here for Justin Mason, they've all been here for 25 plus years, and they've seen it evolve, and it's still, you know, Myron was on the Seedcast, you know, not too long ago, and he said it's simple, you know, and I appreciate that because it's extremely focused, and I don't know. I think it's impressive that how big the train is, and it just keeps rolling on, and everybody hops on board. So,
Yep. Well, awesome. Well, you know, Tyler, thanks for joining us on the podcast today.
Yeah, of course.
And really appreciate you coming on, sharing your information, expertise about Stein and our efforts in research and development and creating new products for growers.
Yeah, of course. No, it's been awesome.
So that's our time for today. I'd like to thank our guests and our listeners for joining us on another episode of the Stine Seedcast. We'll be back again soon with more expert interviews and insights about all things Stein. And to never miss an episode, subscribe to the Stine Seedcast wherever podcasts are found.
Subscribe to the Stine Seedcast wherever podcasts are found. To learn more about Stein and its elite corn and soybean genetics, visit stineseed.com. Stein has yield.